Hey, students, we got 3 weeks left. We're going to start some new stuff here. To be honest, this will be pretty much just algebra, and I think it should be easy if you're comfortable with solving for x and getting all that stuff. If not, we'll just keep practicing and getting with it. Again, here's all the information here for this week and my office hours, but let's get to it. So now we're going to get back to, let me make my face smaller. Now we're getting back to algebra and being able to use variables and putting numbers together, right? We're going to use all those rules such as PEMDAS and all that fun stuff. For the first one here we have is, let's go ahead and do number one, and let's try simplifying. We have A. First thing we got to do is take that 2 and distribute it. That's where we're getting to now. Remember, that means distributing. You're taking that 2 and timesing it to each one of those terms inside your expression, right? Your group. So then you should have 8n squared plus 6n minus 2 times 4 is 8. So that's as small as it gets, right? Remember, we can't combine the n's because one's n squared, the other one is n. And so therefore we can't combine those like terms. All right, let's do B. How about B? Another detail is here we have just right there a subtraction outside the parentheses. That is like saying having a 1 there, and we have to distribute as well. In this case, we're distributing a -1 to each one of those numbers. All right, so now we got 2 plus 4x minus 7x squared plus, remember it's a minus now because -1 times positive 3x is -3x, right? Okay, now we got to combine like terms. What are the like terms you see? Here I have a 4 and 3x. That's the subtraction one, right? So I have 2 plus 1x minus 7x squared. Again, with those x's, that's positive 4 combined with minus 3x, that's positive 1x, all right? I'll highlight that right there, just right there. Okay, last one. Man, this is a lot of work, isn't it? So again, you need to look at your parentheses. There outside, I have that -2. I'm going to distribute that in. So now you should have 3x. You should have 3x plus 2x squared minus 2x. So -2 times positive 3 is -3, right? So now ask yourself, can I combine anything? If you said the x's, you are correct, but you cannot combine the whatchamacallits, your x squared, right? So you got x plus 2x squared minus 3. And again, if I was to get the exact correct answer, I want this in the highest order, we call it, or the 2x squared goes first because that's the highest, then the x, and then your number, right? That would be the more correct answer. Okay, man, this is really good warm-up, actually. It's going to take a bit, but we're good. So number 2, I have here 2 different functions. Remember that? Functions of f, functions of g. Those have their own equations inside of them. So now I need to take each one of those and find the values. For example, f of 2. The f of 2 just means x equals 2. All right? So when I have f of 2, I'm going to use this first function, f of x. And then every x I see, I'm going to replace it with 2. That's all you're doing. Okay? When you have f of a number, you just replace the x value with that. It gets a little bit more complicated, but this is the basics of that, right? So this again gives me 4 plus 3, which is just 7. All right, you should be able to do that with 5 real quick. So I get 2 times 5 plus 3. That's 10 plus 3. That's 13. All right, second part is I'm using g now. So again, we're going to use g for that. So when I have g of 5, that's when x is equal to 5 using this function right here, right? So therefore, looking at it, I got parentheses 5 squared plus 3. When you're using a calculator, make sure you put parentheses or else sometimes the negatives really throw you off, just like with the distance formula back then, right? So that's 25 plus 3, and that gives me 28. Pretty good. Okay, so this is the foundation of what we're supposed to be learning. So again, we're getting into new material. We're going away from geometry. I decided not to give a summative just because I can, and I think make your lives easier. I don't really care. All right, what we learned today, we learned about using the operations of functions. Today's addition and subtraction. So again, it's a lot of algebra. If you're comfortable with it, it will definitely, you'll definitely go through this really smoothly. If not, please remember to pause the video or take your time and do the problems yourself with me, right? All right. So just like with the warm-up, we're going to do the same thing here. I'm looking at now, I have 3 different functions here, right? So I have 3 different functions, and I need to be able to find the values at each function. So again, if I have f of 3, this is when x equals 3. I'll be using f of x, and then we're just replacing that, right? So when you're replacing, remember the parentheses is important. So for every time you see an x, you're just replacing it with that value, okay? So 3 times 3 squared is 9 plus 2, which is 27 plus 2, which should just give you 29. Again, basic algebra rules, or being comfortable with it. Again, this case is when x equals 9. We're using the second one. So now I have 2 to the 9th power. Look at where that x is. That's in the exponent. So then you need a calculator to solve this. Can't do this in my head. So I use my calculator. I get 512. Make sure you get one. You're going to need a calculator throughout today's lesson. All right, h of 6, that's when x equals 6 for the function h, right? So you take that h of x, you replace x with the letter or with the number 6. In this case, we have here 6 squared plus 6 plus 1, which is just 36, plus 6 plus 1 is 7, right? 6 plus 1 is 7, and that gives me 43. Hey, I'm going to pause this video. You try this, and I'll just show you the answers in a bit. Ready? 3, 2, 1, pause. Alrighty, hopefully you paused. Here are my answers. F of 5 is 79, G of 15 is 32,768, and H of 10 is 111. Feeling good? So let's just do another review of adding exponents, exponentials, and some rules with that. All right. Again, I'm trying to speed up because I want to get this video in a good time, but let's do this. Okay. Adding exponentials. So basically, when you're adding exponentials, you need to add things that are the same, the like terms, right? So for example, on the left side, clearly these hearts are the same. Okay, so if I add those 2 up, there's 3 hearts plus 2 hearts gives me 5 hearts, doesn't it? Ooh, I can't draw hearts. Make that a little harder. I have 3 x's plus 2 x's. Well, that's just going to be 5x. A star and a star. So 2 stars, those don't have numbers in front of those. You see that? But that just tells me I have one of those stars, okay? That's 1 star, 1 star. That gives me 2 stars. Let's make this a little harder. This idea applies the same thing with exponents. If I have 3 to the x and 3 to the x, well, this is saying I have one of those, or 1 times 3 to the x, and plus 1 times 3 to the x. So you combine, well, how many of those you have? Well, you have 2, right? You have 2 times of the 3 x's. Again, this gets a little bit harder, but when you're adding exponents, remember, you're trying to find the coefficient of that exponent. When it's just the exponent itself, so 3 to the x, for example, that means you just have one of them. Same thing goes with this next one. I have 1 7 to the m plus 1 7 to the m. All I'm doing is combining these numbers, I'm adding those numbers together, and I get 2 times 7 to the m. Right? This mathematically makes sense because you're just saying is, well, how many of those exponents do I have? If I have that much, then I add those up, right? Or I can subtract. But to make this harder, here I have 3 times 5 to the x plus 2 times 5 to the x. Well, again, I have 3 of those and then 2 of those. So I have 3 5 to the x's, and I have 2 5 to the x's. I have 3 of them, 2 of them, combine them. That's going to be 5 times 5 to the x. All right, the reason why that 5 to the x doesn't turn into a number or anything is because it has that x value, right? We don't know what that is, so we're just going to leave it there. Same thing with the second part. I have here 7 and a 6. Combine those two together, I get 13 of 2 to the x's. Right, I have 13 of the 2 to the x's. Same thing goes here. It looks like I have 3 plus Ooh, actually, I'm tripping out. So again, because these are not the same, these right there are not the same, can I combine them? If you said no, then you are correct. I cannot combine them. But here's another detail. If I have here, let's see, 3 times 8 to the x plus 5, or 3 times 5 to the x. Well, another math rule is, remember, is that we have a common number here. These are common factors. So even though I can't combine 8x plus 5x, I can actually factor out a 3, all right? And so when I'm going reverse with this, I factor that out. What I have now is 3 times 8 to the x plus 5 to the x. All right, so you're factoring out a number. You're going to do this a lot in 10th grade. This is like 10th grade math, secondary math 2, like 100%, right? That's what you dive right into. Okay, let's make it a little bit harder. So now we have composition of functions. I built the foundation of doing those problems, and now we're going to put these all together. All right, so basically all a composition of functions is when I take two functions, in this case fx and gx, and I'm going to combine those values. All right, so what I'm trying to say is when I have something like this is what I'm going to give you, right? That translates to basically this. So f plus g of 6 translates as f of 6 plus g of 6. All right, so when I put that in, I'm going to take that 6, that's what x is going to be for the f function and for the g function, or the red and green. All right, so I'm going to take those functions. In this case, f of x is 4 times, in this case, 6, right? This comes from this right here. I just highlighted it. All right, plus 8. So that's its own thing. That right there is the f of 6. And now I'm going to add the g of x part, which is 2 parentheses 6 minus 12. Again, I'm trying to go a little bit slower because I'm trying to be concise. But again, all that is I'm taking that 6 and putting it into x for each function. All right, and that one's for the g of x, or the green function. I could simplify this to, well, 4 times 6 is 32, or no, it's 24 plus 8. That's 32. Plus 12 minus 12, which is 0. So I get 32 plus 0, and that answer is 32. And that is going to be the same answer as this side, the left side part, all right? So again, when I have this notation over here, over here, basically you take your f function, your g function, you add them together. Don't forget the parentheses. You got to group them up, right? So this is where the parentheses matter. If I give you f minus g of 2, well, that transfers into this right over here. And so I'm going to take 2 now and replace x with 2 for each one of those functions there. All right, let's try to do this quicker. So I got 4, parentheses 4, x is 2 now, plus 8, and I'm going to close it, right? That's your f function. That's the f function in red. Plus, or minus, your g function, which is 2 parentheses 2 minus 12. So this is where that warm up that we just did is going to be helpful. All right, so notice how now I have this minus right there. All right, right there. That means I need to distribute that subtraction, right? This is like saying, there's a minus here. This is like saying minus 1 parentheses times the parentheses group, right? So now I have to distribute that through. So 2 times 2 is 4. Let's just simplify the left side of this equation. We got 8 plus 8. We got minus 2 times 2 is 4, so we're going to times it by -1 is -4. And then -1 times -12 is plus 12. All right? Make sure you do your order of operations, or I can say 8 plus 8 is 16, minus 4 plus 2, which is going to give me 12 plus 2, which is just 14. So my answer for B, for f minus g of 2, is 14. All right, that's a little long, right? But please pause this video and take some time with it. Again, this is a lot of algebra, but what you're doing is just using the calculator, putting numbers in, and then just combining it. The little rules are as those negatives. All right, so we got a couple more of this. Let me show you another example. So now, instead of having just like straight up x's and numbers, I have here an x squared now, right? That exponent. This is going to change a little bit, but let's just go on with this. So if I have f of g, or f plus g times 3 of 3, that turns into where your x is now equal to 3, and you add those two together. Okay, I'm going to try to go a little faster with this. I know I keep saying that, but I really want to be good with time. All right, so that's your first group, plus your second group. That's your first group, plus your second group. And let's see, which is going to be 3 squared. That's the g function. So that just gives me 6 plus 5 plus 9. Combine all of that, 11, that gives me 20, right? All right, now what happens if you do subtraction? It's going to change everything, right, if you do subtraction. So now x is equal to 2 for both functions. All right. Okay, so I got parentheses, 2 times 2 plus 5 minus parentheses 2 squared. So this is tricky because you're going to think, oh, I can just subtract it through, but you need to do the square first, right? This goes with PEMDAS, where you have to do the parentheses first. Right now you have 2 parentheses. So you get 4 plus 5. Remember, there's a -1 out here. So I'm going to leave that there for now, okay? -1 parentheses 4. Well, -1 times 4 is just -4. So this is 4 plus 5 minus 4. That's just going to be 5. All right? Man, that's a lot of work, right? But you can do this. Again, take your time, pause it, make sure you understand the negatives. That's going to be the thing that's going to throw you off. I guarantee it. All right. So let's try to throw this a little bit harder. Okay, let me just set up some notes so that I can make sure that I'm getting this right. Let's see, here we are. So again, we're going to do the same thing, but now we're just going to add with no particular values of x. All right, now we're just going to straight up combine the functions together. So again, if I was to combine those two functions, I have f plus g of x. Well, what that looks like is f of x plus g of x, which should just be like that. Again, I'm going to combine the like terms. Notice how this and this x are not the same, not same. All right, so I can't combine those, but I can combine the 5 and the 2. So what I should have is 2x plus 5 plus x squared plus 2. I can combine the numbers together. What that should give me is 2x plus x squared plus 7. To be correct, you have to do the highest, I forgot what it's called just now, highest degree, and then go down to the numbers, and that's your answer. All right, so same thing with f minus g of x, in terms of the f of x minus g of x. Well, that looks like this. Keep in mind, you have to subtract everything in the function. Again, there's that 1 right in front of it, right? You need to distribute that. You need to take that and wind it back. Just kidding. Okay, so that's going to be 2x plus 5. And you distribute that negative that subtraction sign, that's minus x squared minus 2. I can combine my numbers. That's going to give me 2x minus x squared plus 3, which is the highest degree is negative x squared plus 2x plus 3. There you have it. That's a lot of work, isn't it? Again, pause this video if you're stuck. Hey, let's do this one, and then that will be it for the lesson. Let me see. Yeah, let's just do this one together. That's totally fine. Again, you can pause this video or fast forward if you understand what's going on here, but I'm going to take it down a notch. Okay, so I have here f plus g of x. So I'm going to take my f function. So this is equal to f of x plus g of x. I'm going to combine those two together. So I do that, I get 4x minus 1 plus 2x plus 9. Well, this turns into 4x minus 1, right? Parentheses go away. Then I combine the like terms. Ooh, notice how the x's are the same too, right? You have 4x plus 2x. So that's going to give me 6x plus 8. And that is my general solution. Okay, a trick about this is if I was going to do B, C, and D over there, right? Well, all this is saying that the f plus g is the same function operation, the composition. But except I put a number there, that's just saying x equals 1, x equals 5, x equals 0. And that shortcut. So now I just take my function right over here, right, and just put it in. So 6, 1 plus 8, that's just 14. And then this one is going to be 6, 5 plus 8, that's just 38. And then you throw in that 0, that's just 8. Okay, that's it for the lesson today. Here's the discussion question. It's going to be down below. This time it's kind of like a Canvas activity quiz thing where you have to put an answer in, right? Just some hints as well. Remember, this is subtraction. This is subtraction, so don't forget the negative, right? Don't forget the negative. Don't forget to distribute it. But besides that, learn today is about operators, functions, addition, subtraction. We'll do a second day to this tomorrow. And yeah, that's it. Yeah, I put a learn activity up and go ahead and answer the question. Please come to my office hours. I understand that this may be hard for some of you who struggle with algebra, but no worries. I got your back. Take care.